Hello. So in this video, we're gonna go over geometric sequences and series. So previously we looked at arithmetic sequences and series. So in arithmetic sequence and series, you had some first term, and then your next term was just adding a constant, what we call the common difference. So that was your second term, and your third term was a plus 2d, and so on. So this was an arithmetic sequence. I'm not going to write it out. So a geometric sequence is very similar, except addition, you're doing multiplication. So you have your first term, a, and then you're multiplying some constant r to get your second term. And your third term is ar squared, your fourth term is ar cubed, and so on. So this r is what we call the common ratio. And let's look. Our first term, so what we call n here. So our first term is a. Our second term is ar. So can I write just a as a times r to the power 0? Because that will help me look at things. My third term is ar squared. So if you think about it, my powers are increasing. 0, 1, 2, 3, and so on. And how are they connected to my n? Well, 0 is 1 minus 1. 1 here is 2 minus 1. 2 here is 3 minus 1. So therefore, your nth term is going to, all of them have a, and your r is just going to be n minus 1. 3 minus 1 is 2 minus 1. So minus 1 minus 1. So that is going to be your nth term. So this is the formula that we're going to be using a lot. Now, if you're given, like, say, 2, 4, 8, so this is geometric. How do you find r? Well, you divide the second term by the first term, or you divide the nth term by the term before it, the n minus 1th term. So that is how you're going to calculate the value of r. All right. And another way to express a geometric sequence is that the nth term is just the previous term multiplied by r. So this is consistent with the definition that we have looked at. Now, that is almost all the formula you need. What is a geometric series? Well, a geometric series is just what happens if you add all of these terms together. And we call it sum of n terms. So we want to add up all the first n terms. Well, we just looked that the nth term would be ar to the power n minus 1. So let's multiply this Sn, this whole series, by r. So what happens if we multiply by r? We get r times Sn. So the first time multiplied by r is ar. Your second time multiplied by r is ar squared. Your third term is going to be ar cubed. Your fourth term is going to be ar4, and so on. And your last term is going to be ar to the power n. Now, if I subtract these two equations, I see that on my left-hand side, I'm just going to get Sn minus r times Sn. On my right-hand side, well, I can't really cancel anything out, so I'm just going to keep my a here. If you think about it, I have plus ar from my first row. This is row 1. So I'll call it row 1. This is row 2, right? And I have a minus, the same thing. I'm subtracting ar in my second row. So these are going to cancel out. And these are going to cancel out. And basically everything on these diagonals are going to cancel out. And remember, we're going to have r n minus 1 here for my second row. So these will also cancel out. So the only thing left is ar to the power n. And don't forget the negative sign because we're subtracting. So we're going to have minus ar to the power n. So I can factor out Sn, and I'm going to get 1 minus r on my left-hand side. On my right-hand side, I'm going to get 1 minus r to the power n. So therefore, the sum of n terms is given by 1 minus r to the power n divided by 1 minus r. Now, another expression I will get, so you can remember this one. But another expression is, what if I multiply by negative 1 in my numerator and my denominator? Then I would get ar to the power n minus 1 divided by r minus 1. So both formulae are valid. So these are almost all the formula that we're going to use. And now let's just look at the questions. All right, so the first question is just we're going to identify if something is geometric or not. And if it is, we're going to calculate the common ratio and the 8th term. So let's see. 4 divided by 2, that is 2. 8 divided by 4 is also 2. 14 divided by 8. So remember, to calculate r, you do the nth term divided by the previous term. So 14 divided by 8 does not equal to 2. So a is not geometric. All right, so A is not geometric. Let's look at B. 21 divided by 7, that is 3. 63 divided by 21 is also 3. 189 divided by 63, you're going to see that it's going to be 3. So you can do it, or you can think of it in the other way. 7 times 3 is 21. 21 times 3 is 63. 63 times 189 is 63 times 3 is 189. So therefore, this is geometric. B is geometric. So your R is 3, which we got by dividing the nth term by the previous term. And then your 8th term, T8. So remember the formula. Tn is AR to the power n minus 1. So T8 is going to be AR to the power 7. 8 minus 1 is 7. And that is just going to be, so A is your first term. 7 times R is 3 to the power 7. And if you calculate it out in your calculator, 7 times 3 to the power 7, that is just 15,309. All right, so that is your answer for 2. 15, R is equal to 3, and your 8th term is 15,309. 309. All right, so for C, if you divide negative 27 by 81, you get negative 1 over 3. You divide 9 over negative 27, you also get negative 1 over 3. And if you do it again, you see that you get the same value of R. So R is just going to be, this is geometric because you get the same R when you divide the nth term by the term previous. Or you can think of it as multiplication. 81 times negative 1 over 3 is going to give you negative 27. Negative 27 times negative 1 over 3 is going to give you 9, and so on. So your 8th term is going to be AR to the power 7 again. So that is going to be 81 times negative 1 over 3 to the power 7 again. So remember, 81 is just 3 to the power 4. You have negative 1 to the power 7 from the numerator, and you have 3 to the power 7 in the denominator. So if you simplify this, you're just going to get negative 1 over 27. So 3 over 4 divided by 3 over 7 is just 3 cubed is negative 1 over 27. So now I've done it a bit quickly, but I'm sure you're used to the algebra by now. I hope so. So now the next question. So we've done 3. So our R was negative 1 over 3, and our 8th term was negative 1 over 27. All right. So now let's look at D. Well, to get to 2 over 9 from 1 over 9, I'm multiplying by 2. I'm multiplying by 2 to get from 2 over 9 to 4 over 9. But if I multiply by 2, I should be getting 8 over 9. But I don't. So D is not a geometric sequence. Let's look at E. So to get to 0.4 from 1, I'm multiplying by 0.4. 0.4 times 0.4, that is 0.16. So we are still multiplying by 0.4. But if you check 0.16 times 0.4, that is not equal to this. So this is not geometric as well. E cannot be geometric. And another way to think about it is that if R is less than positive 1 and greater than 0, right? So R is between 0 and 1. The bigger power you take of R, the closer it gets to 0. So if n tends to infinity, if n gets bigger and bigger and bigger, R to the power n gets closer to 0. And that is what is happening. Because you're multiplying by 0.4, and 0.4 is less than 1 but bigger than 0, these numbers should be getting smaller and smaller. So 1 is the biggest, 0.4 comes next, 0.16 is less than 0.4, and this should have been even lesser, but it's not. So E is not geometric. And finally, we have F. So 1 times negative 1 will give you negative 1. If you multiply by negative 1 again, you get positive 1 and negative 1, and so on. So your common ratio is negative 1, and it's consistent. You can't, and to calculate the 8th term, you can use the formula, but let me give you another way. So your first term is positive 1, your second term is negative 1, your third term is positive 1, your fourth term is negative 1. So 2 is even, 4 is even, and because we want the 8th term, 8 is even, then it's going to be negative 1 based on the pattern. So R is negative 1, and your 8th term is also negative 1. So that is it for question 1. So we're done. Question 2. The first term in a geometric progression is A, and the common ratio is R. Write down the expressions for the 6th term and the 15th term. Well, that is just using Tn is equal to AR to the power n minus 1. The 6th term will be AR to the power 6 minus 1, which is just 5. And the 15 term is AR to the power 15 minus 1, which is just AR to the power 14. All right, we're done with question 2. Question 3 says, the first term is 207. So first term is A is 270. And the fourth term is 80. So T1 is equal to A. T4 is AR cubed is equal to 80. It says find the common ratio. Well, what can I do? I have T1 and I have T4. What if I divide the two expressions? AR cubed divided by A will give me 80 because AR cubed is 80 and A is 270, right? So this is going to simplify. Remember, the A's are always going to cancel out. So you thinking of division might be useful because things are going to cancel out here. So I have R cubed is equal to 8 over 27. And remember, 8 is 2 cubed, 27 is 3 cubed. So therefore, this gives us R is going to be 2 over 3 cubed to the power 1 over 3, right? And by the power law, these two multiply out. So you just get 2 over 3. That is going to be your R for question 3. All right. Question 4. The first term is 50. A is 50. And the second term is negative 30. So AR is negative 30. And again, we can divide. If I divide AR divided by A, I'm going to get negative 30 divided by 50. And the zeros cancel out. And the A's cancel out. So R is just negative 3 over 5. And I want the fourth term. So T4 is just AR to the power 4 minus 1. AR cubed. A is 50. R is negative 3 over 5 cubed. And if you simplify, you get 50 is just 5 times 2, right? Negative 3 cubed is negative 27. And 5 cubed is 125, which is 5 times 5 times 5. So upon simplification, you get negative 54 divided by 5, which is negative 10.8, I believe. And that should match the answer given in the textbook. All right. So the simplification, because we've sort of been doing this algebra for a while now, I'm doing it a bit quickly to save some time. All right. Question 5. The second term of a geometric progression is 12. T2 is 12. So AR is 12. And the fourth term is 27. T4 is 27. AR cubed is 27. Given that all the terms are positive, so if all the terms are positive, think about it, R has to be bigger than 0, right? If your first term was positive and your R was negative, then your second term should be negative, but it's not the case. If all the terms are positive, R should be positive. It says find the common ratio and the first term. So again, I'm going to think of division. AR cubed divided by AR is going to be 27 by 12. So A's cancel out. R cubed divided by R is R squared. And 27 by 12, well, that's 9 3s are 27. So 9 by 4, right? 3 times 9 is 27. 3 times 4 is 12. So the 3's are going to cancel out. R is equal to, so because a positive or a negative 3 by 2, because remember, 9 is 3 squared, 4 is 2 squared. So if you simplify, you will see that positive or negative 3 over 2 squared will still give me 9 over 4. But we have already decided that R has to be positive. So we're going to take positive 3 by 2. So that is the common ratio. And the first term, A is just T2 divided by R is T2 divided by T1. Remember, R is Tn divided by Tn minus 1. So if n is equal to 2, which is given to me in the question, then R is just T2 divided by 2 minus 1. Right? So R is just T2 divided by T1. Well, we know what R is, and we don't know what T1 is. So T1 is going to be T2 divided by R is going to be T2 is just 12 divided by 3 over 2, and that simplifies to 8. So for question 5, your answer is 8. Sorry, I'm lost. Okay. Now question 6. The sum of the second and the third term in a geometric progression is 84. So all the terms are positive. So r must be bigger than 0 again. So we're given t2 plus t3 is equal to 84. So ar plus ar cubed, second term is ar, third term is ar cubed, is equal to 84. That is what we are given. And the second term, ar, is equal to, second term is, so is means you put an equal to 16 less than the first term. So if your first term is a, then a minus 16 has to be your second term. Now how can I solve this equation? Well, you want to think, what can we substitute? Well, from this equation here, I can see that r is just a minus 16 divided by a, right? And I can substitute this value of r here. So if I do so, I get a times r, which is a times a minus 16 divided by a, plus a times r, no, t3 is ar squared, sorry. So I'm going to have r squared here. R squared is equal to 84. Now let's simplify. A's cancel out, so you get a minus 16 plus a times, the numerator is a binomial expansion, and we have been doing this. So you're going to get a squared minus 32a plus 16 squared. That is 256. Divided by a squared. We're going to have to square this as well, a squared. So we did the numerator square, and we have to square the denominator as well. That is 84. And remember, a and a squared. So that is going to cancel out and leave one a in the denominator. Why? Because you can write a squared as a times a, and one of the a's are going to cancel out. Now if I multiply by a on both sides, and the reason why I'm doing this is because I want the a in the denominator here to cancel out. I don't like working with variables in the denominator. So a times the first term gives me a squared minus 16a. And this a, when I multiply on my second term, well, the denominator, the a in the denominator is going to cancel out. So these are going to cancel out. So I multiply first with my first term, and then it's going to, when I multiply it with my second term, the a in the numerator and the denominator are going to cancel out. So I'm just left with whatever I have in my numerator. A squared minus 32a plus 256. That gives me 84a. Now let's simplify. A squared plus a squared, 2a squared, minus 16a minus 32a minus 48a plus 256 is equal to 84a. Now let's divide by 2 on both sides. I get a squared minus 24a plus 128 is equal to 48a. And if I bring all the terms, so if I subtract 48a on both sides, I get a squared minus 66a plus 128 is equal to 0. And this is something we can solve using the quadratic formula. So a is going to be plus or minus b, so minus of minus 66, is that is positive 66, plus or minus the square root of 66 squared. That is 4356 minus 4 times 1 times 128. So 4 times 1 times 128 gives me 512. So 4356 minus 512, sorry, is 3844. So inside the square root, you will see that I have 3844. And the square root of 3844 is 62. And divided by 2a. Don't forget, divide by 2a. So 2 times 1 is just 2. And if you solve this, you get two values of a. You get a is equal to 2 and a is equal to 64. So which do you select? There's only one answer. Why? Well, you are given that r has to be greater than 0. So remember, your r is just a minus 16 over a, right? So from this, if a is less than 16, then you're going to get a negative r, right? So we don't want a negative r. We want a, all terms are positive, so a is bigger than 0. And if a is less than 16, then r is negative. If this is the case, then r becomes negative. Why? Because within this range, if you take away 16, then you're going to get a negative number. And this is not what we want. So a cannot be less than 16. So 2 is less than 16, so you have to reject this. So A is 64. And you can actually substitute in and calculate the value of R and check when do you get negative. And if you get negative, then you gotta cancel out. That is not gonna be a correct answer. Why? Because we are given in the condition that all terms are positive. So yeah, the first term is just 64. And that is it for this video, and we'll be solving more questions in the next one.